Hey guys, it's Cherry and welcome back to my channel. So in my last video, I went through chemical reactions, including what they are, how to identify them, and some basic type of reactions. And in today's video, I'm going to be showing you how to write and balance your own chemical equations. Now this is the fourth video in my Intro to Chemistry series, and for now it's kind of the last one. But if you have any questions or video ideas about chemistry, make sure to leave them down below in the comment section and I'll see what I can do. Now let's get into today's video. So to recap, a chemical reaction is when the atoms of two or more substances rearrange to form something new. So essentially, it's the making and breaking of chemical bonds. Your reactants are the starting substances and these appear on the left side of the arrow, while your products are the ending substances and they are on the right side. Chemical equations are used to describe the different reactions, and it shows the change from reactants into products. These can be written as word equations or symbol equations. And word equations are very simple because they only describe the reactants and the products. Whereas a symbol equation also tells us how many of each type of atom is present. Now in this video, I'm going to be showing you guys how to write a symbol equation, and there are two main steps in this process. Step 1 is to determine the symbols for the substances involved. We need to first identify whether a substance is an element or a compound, and referring back to my first video, we know that an element consists of only one type of atom, while a compound is made up of multiple different types. If a substance is an element, we simply write the symbol which can be found from the periodic table. It's important to note that some elements such as oxygen and hydrogen appear as diatomic molecules, meaning they exist in pairs, so these will be written as O2 and H2 rather than O and H respectively. On the other hand, if a substance is a compound, we need to identify the type of compound, and this can be either covalent or ionic. Covalent compounds are made up of two nonmetals, while ionic compounds consist of a metal and a nonmetal. If a substance is a covalent compound, you will need to remember the following prefixes. Mono means 1, di means 2, tri means 3, and so on. These prefixes tell us how many of each type of atom is present. Firstly, you will write the symbol for the first element within the compound, and then write the subscript for this element, and this is based off the prefix. Once you've done that, you repeat steps 1 and 2 for the second element. For example, in sulfur dioxide, the first element sulfur will simply be written as S as it does not have a prefix, and the second element, oxygen, will be written as O2 as it has the prefix di, which means 2. So altogether, this compound will be written as SO2. If the substance is an ionic compound, you will need to find the symbol and valence charge of the cation and anion, and this can be done using a valency table. It is important to note that cations always have a positive charge, while anions always have a negative charge. Once you've done that, you need to find the ratio that is required to balance the positive and negative charges of the ions, and this ratio will be written as subscript. For example, in lithium oxide, the cation lithium has a charge of 1+, while the anion oxygen has a charge of 2-. Therefore, you need 2 lithium atoms for every oxygen atom, and this means that the symbol for this compound is Li2O. Step 2 is to balance your equation, and this is the process of making sure that you have the same number of each type of atom on both sides of the arrow. Balancing equations is done to satisfy the law of mass conservation, and this law states that mass cannot be created or destroyed within an isolated system. Now this might seem a bit confusing now, but let's look at it within some examples. The first example is zinc plus hydrochloric acid, which forms zinc chloride plus hydrogen, and in this example, zinc is a pure element, so we'll just write its symbol. Now hydrochloric acid is an ionic compound, so we need to find the symbol and valence charge of hydrogen and chlorine. We know that hydrogen has a charge of 1+ and chlorine has a charge of 1-. Next, we must determine the ratio that is needed to balance these charges, and then write this ratio as a subscript. Because we only need one hydrogen atom for every chlorine atom, they already balance each other out, and hydrochloric acid is simply written as HCl. So now our reactants are Zn plus HCl. Now let's move on to the product side. Zinc chloride is also an ionic compound, so we'll do exactly what we did for hydrochloric acid. Zinc has a charge of 2 plus and chlorine has a charge of 2 minus. So for every zinc atom, we need 2 chlorine atoms. Therefore, zinc chloride is written as ZnCl2. Finally, hydrogen is diatomic, so it appears as H2. So now our products are ZnCl2 plus H2. Our full equation is written as Zn plus HCl becomes ZnCl2 plus H2. So now all that we have to do is check if it's balanced. We have one zinc atom on both sides of the arrow, however there is one zinc and one chlorine on the reactant side, but there's 2 zinc and 2 chlorine on the product side. So to balance this equation, we must simply add a 2 in front of the hydrochloric acid, and this becomes the coefficient. So now we have 1 zinc, 2 hydrogen and 2 chlorine on both sides of the arrow. Therefore, this equation is now balanced. Now let's look at another example. Example 2 is sulfur dioxide plus oxygen, which creates sulfur trioxide. We can instantly tell that sulfur dioxide is a covalent compound because of the prefix di. So this will be written as SO2 because di means 2. Oxygen is an element, so we'll just write its symbol, but because it's diatomic, it appears as O2. So our reactants are SO2 plus O2. Moving on to the products. Sulfur trioxide is a covalent compound, so it will be written as SO3 because the prefix tri means 3. Now the full equation is SO2 plus O2, which becomes SO3. The last step is to ensure the equation is balanced. So we have 1 sulfur atom on both sides of the arrow, however there are 4 oxygen on the reactant side, but only 3 on the product side. So to balance this equation, the first step is to make sure that we have an even number of oxygen atoms on the product side. And we do this by adding a 2 in front of the sulfur trioxide, which gives us 2 sulfur and 6 oxygen on the product side. And to do the same thing on the reactant side, we must put a 2 in front of the sulfur dioxide. And now we are left with 2 sulfur and 6 oxygen on both sides of the arrow, therefore balancing this equation. So there you have it. Now you know everything there is to know about writing and balancing chemical equations. I hope you guys enjoyed this video and learnt something new. And if you did, make sure to like, comment and subscribe to my channel for more. Thank you so much and I'll see you guys next time. Bye!